problem 8.24, sum the following series. Okay, so in this case we want to identify this series with some Taylor series that we know, right? And see if we can get the value of the sum, right? So this is the sum from n equals 0 to infinity, and then we have minus 1 over 2 to the n divided by n factorial. Okay, if you try and remember a Taylor series that goes like this is x to the n over n factorial when x is equal to 1/2, right? But this, sorry, minus 1/2. But this is e to the x, right? You remember, so this is just e to the minus 1/2. This is what this exercise is asking us to do. Okay. Okay. Now let's deal with this. Let's see. Sum. This is the sum from n equals 1 to infinity of n divided by 2 to the n. This is an arithmetic geometric series, so you know the formula. But let's see if we can compute this. This is the sum from n equals 1 to infinity times n to x to the n, where x is 1/2, right? Now this is just x times the derivative of this function x to the n when n equals 0 to infinity, right? Right? The derivative of this is n times x to the n minus 1 times x. You get that? All of this evaluated at x equals 1/2. Now the derivative, this function is 1 over 1 minus x if x is between, sorry, the absolute value of x is smaller than 1, but in this case that's true. So this derivative of this, we know that this is x divided by 1 minus x squared. This is x because this is multiplying here, and this is evaluated at 1/2. So this is 1/2 divided by 1/2 squared, so 1/4. This is 1/2 over 1/4. This is 2. Okay. Okay. Now let's see. Part 3 is the sum from n equals 1 to infinity of 1 over n times 2 to the n, and this is the same as n, the sum from n equals 1 to infinity of x to the n divided by n when x is equal to 1/2 again, right? And again, the sum of this is, we know that this is minus the logarithm of 1 minus x. You have to remember this kind of series. So this is minus the logarithm of 1 minus x when x is 1/2. So this is minus the logarithm of 1 minus 1/2, and in other words, the logarithm of 1/2 minus the logarithm of 1/2 is the same as the logarithm of 2. Okay, and then finally what we have is part 4, the sum from n equals 0 to infinity of minus 1 to the n 2n plus 1, and this is the same as saying sum from n equals 0 to infinity of minus 1 to the n times x to the 2n plus 1 actually over 2n plus 1 when x is equal to 1. So if you go to your table of series, this is actually the series of the arctangent of x. Okay, this is one of the easy ones to remember, so it's actually useful to remember that one, right? So this is the arctangent at 1, and we know that the arctangent at 1 is pi over 4.